Okay, so the second issue that I want to bring up about why we don't do a good job of solving problems in schools has to do with the means. Now, again, going back to the other video, we're going to assume for just a minute we're actually supposed to be using means here. So I'm going to give you an example of a situation where somebody wanted to see if being in a book club would make a difference or not in terms of the number of books read. So this is just a normal distribution. These are the students that are in the book club. These are the students who are not. And right here, let's see if I make that a little bigger. You can see the mean for each of those. So on the surface, we would assume that being in the book club makes a difference because the kids in the book club are reading more books than the kids who aren't. Now this is the same data, but it's represented in a different way. But again, what I want to show you, and this is what catches people, the mean is 7 for in the book club, 5 for not in the book club. So again, on the surface, just comparing the means, we'd assume that, hey, being in the book club means that kids read more books. That's not true at all. So here's what those look like side by side. So in this situation, outcome A, the kids who are not in the book club are in the blue. The kids that are in the book club are in the green. Same situation over here. So what you can start to see is how these students are distributed is pretty similar across the group in B, but they're kind of different in A. I'm going to go back for just a second. I want you to look at the standard deviation for these. Here, it's 1.6 and 1.8. Here, it's much larger. It's 3.8 and 3.5. So a visual representation of that means that the standard deviations in this situation are much narrower than they are here. And that kind of makes sense because with a broad standard deviation in both groups, that means they're overlapping with each other. So I'm going to show you another example of this that I came up with. So again, this is in the book club, not in the book club in situation A. In the book club, not in the book club, situation B. So on here, the normal distribution lines are included as part of the standard deviation. So you have the mean and this red standard deviation. Here is situation B. So I want you to see how much of these two red lines overlap each other. The point of all of this is even though the means are exactly the same, in one situation we see a significant difference, in the other we don't. So here's outcome A. There's 15 that were in the group, 14 not in the group. As we saw, there's the mean for in the group, not in the group. This is kind of a detailed issue, but this Levene's test has to do with how well we can assume the variances are distributed. In this situation, we're going to assume that they're distributed evenly. So here, we see that there is a significant difference. It's less than 0.05. That means that in situation A, yes, there really is a difference between being in the book club and not being in the book club. In situation B, again, the means are exactly the same, but the standard deviations are much broader. So now there is not a significant difference. So when we talk about why we need to run tests, why those matter, it matters tremendously It's the difference between knowing something and not knowing something. And that's one of the frustrations I have with people relying simply on means, because that is the only part of the equation. It's the standard deviation that really makes a difference. So why do we do a poor job of this in schools? It's because we don't really realize all of the tests that we need to take advantage of in order to compare to groups, 3 groups, compare a group to itself, compare multiple groups to themselves, to correlate, and we'll talk about what all these tests mean. And that has to do with whether it is real numbers, this Gaussian distribution, or ranker score numbers or non-Gaussian distributions. Remember from the last post I made, the last video, making a choice between a Mann-Whitney and an unpaired t-test or an independent t-test is really important because you can get a different answer. It's important to choose one of these because by simply relying on the means and not looking at the standard deviations and not running a test, you can't know. So when I ask the question, can you really know? We can and we can't. We can't in the sense that there's so many things we don't have control over in the variables, but we can do a better job than what we're doing by at least running some measure of tests. Why this doesn't happen in schools, I'm still not completely certain on, because people who get their master's degree, certainly people who are in their doctorate or the PhD, knows this needs to occur, yet it never does. And I think what we always fall back to is, well, we just need a solution. But we never take the time to really determine whether or not that solution worked for us. And I'm all for trying solutions to problems, but let's test it to see if it works and have the good sense to stop if it's not working. So that's just a real short video about why we need to do this, and I will post some other things for a discussion thread.